Hello everyone, welcome back to alkaline hydroxide 784, and today in the chemistry series we will be doing the mole concept and stoichiometry. This definitely looks shorter than the periodic table one. And I think the stuff that is covered in it is also quite short, so yeah, looking for a hopefully not very long episode today. So before we start, of course at the top of the learning outcomes it says the term relative formula mass or MR will be used for ionic compounds. Yeah, just take note of that. So let's just go through the learning outcomes. The first one is defining the terms relative atomic, isotopic, molecular, and formula mass. Okay, the reason why there's the word relative is because it is being compared to a certain standard. I know there were some changes in the whole what exactly it's being compared to, but as of now, I believe it is being compared to the carbon atom. So 1/12 of the carbon atom in a sense. So if you're looking at atomic, you'd say the mass of the atom with regards relative to the mass of 1/12 of the mass of a carbon atom. So like 1/12 of the mass of a carbon atom is 1 AMU, and atomic mass is based on AMU. So yeah. Isotopic isotopic is actually everything is pretty similar. It's just that atomic is for atoms, isotope for isotopes, I suppose. Molecular is for molecules, and formula mass is the one that's used for ionic compounds. So just remember that, yeah. Define the term mole in terms of the Avogadro constant. Yes, the constant that we all like to call avocado. Sorry. Anyway, so a mole is uh yeah the number wait sorry one mole of a substance is the amount of substance that contains an Avogadro constant's worth of molecules or atoms or whatever that you call it of that substance, of the particles of the substance, I suppose. Yeah, that's one more. Next one, calculate the relative atomic mass of an element given the relative abundance of its isotopes. Okay, this is very easy to do. So you have your isotopes. I'll try to write an example here. And each of them has their own mass, right? And you also need to know the abundance of the isotope. And from there, if you look at the percentage, you just times the percentage by the mass, and then you just add all of them up, and then you get the relative atomic mass. Oh, okay, that's why it's relative. It's not just one atom individually, but it is the relative is still because of the comparison, but for atomic mass, you must be aware that it is an average. It is the average mass of the atoms of the substance. If you think about it, yeah. That's why there's the isotopic one as well. Isotopic is for the specific isotope, whereas atomic is overall mass of that object of the element. That's why your values in the periodic table are not whole numbers, but instead a bunch of decimal places. It's because of all of the isotopes that are involved in it. So the next one, empirical and molecular formula. Okay. So empirical and molecular formula. So the empirical formula is like the ratio, like the molecular formula is the actual formula of that thing. So let's say if you have CO2 is CO2, you have NH3 is NH3, if you have Al2Cl6 is Al2Cl6. Whereas the empirical would be AlCl3, for example. So that's the difference between empirical and molecular formula. I think this will be more applicable to something that's like an organic compound, maybe. Yeah, maybe it's like C3H6, and you could reduce that to CH2, which is the empirical formula. Yeah. Yeah, you might be wondering whether C3H6 is an actual thing. I guess it could be, yeah. Makes sense. So yeah, let's go on. Next one. How to calculate this formula then? yes, you have this question that we like, oh, blah 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 blah, the composition of we weighed this thing and then this was the composition, blah 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 blah, and then you had to find out the formula from there. So when you get this information, um, take note of if you're working from masses, you have to take note of the percentage of mass for each of them. To make your life easier, just put like how much mass there will be in 100 grams, and then you just put the masses itself. Don't put the percentage because that will be a bit too annoying to calculate. And after you get the mass, and then you get the amount that will be in that mass. So because different elements have different atomic mass, you can then calculate how much of the element is there within that mass of the element. And from there you can compare the amount relative the ratios of the amounts, and from there you can get your formula. Yeah, that's pretty much it. You get the empirical formula, and the combustion data or other information will help you then make it into the molecular formula. So for combustion data, you can also use it for this general question, but it's usually based on combusting a certain hydrocarbon, and then you get a certain x and y, and from there you have to calculate the the CXHY, that part. Yeah, that's pretty much what they expect you to do. Okay, so next one, write and or construct balance equations. I guess I can't really help you in this. It's just you just have to do it yourself. I mean, one way to make sure that it's balanced is to literally see whether both sides have the same number of the particular element, and all those things. Yeah, and whether they make sense to begin with. Okay, so the next one, to perform calculations including use of the mole concept involving reacting masses from formulae and equations, volumes of gases in the burning of hydrocarbons, volumes and concentrations of solutions. And you must make sure you write the right number of significant figures asked for in the question. Right. So I guess this one is based on like those questions where you see a certain formula or certain equation, and from there you have to figure out how much of it's like if this certain mass of A reacted with a certain mass of B, what happens, and what is the resultant mass, or what is actually there's mass conservation, but like what's the mass of the product maybe, or what's the volume of the product maybe, because when you burn hydrocarbons there may be more moles of gases compared to what it started out as, right? So the volume will increase, and if you're assuming ideality of the gases, the volume will increase proportionally to the moles of the gases, given that your pressure is constant. I just saying this because I have to worry about that kind of stuff in one of my modules, so yeah. Just ignore me for some seconds, but yeah, you get the idea. The volume proportional to the moles, and then the volume and concentration of solution is based on how much solution is added to how much other solution per volume, and whether there's any gas that escapes from the solution which decreases the volume of the solution or the concentration of the solution or whatever that is. So do take note of all of these factors, and if you need to draw a table, please draw a table. If you do not need to draw a table, then just go ahead and do what you can do. Make sure to do it properly and get your calculator, type all the stuff properly, understand what you're doing, and I think you'll be able to do this properly. Yeah. The thing is, this topic doesn't really have much of content per se, it's more of applying it properly. So yeah, I'll just like actually the last learning point is just deduce stoichiometric relationships from the calculation. So I can't really say anything else much lah, but usually when you calculate, sometimes you can find that one particular thing has 2 times the number of moles as the other one, and then from there you can get the stoichiometry. So that's the idea lah. So I'll just end it off with some tips about questions like this, and we can end. Actually, this been it's barely 10 minutes. Wow, that is crazy. Okay, so when it comes to these questions, The most important thing to do is to read the question as much as you can, like read it properly. Make sure you don't leave out any of the details that you need for answering it. And if you feel like there's not enough information, then read the question again, or maybe just look through whatever data you have and see if there's something that you missed out in terms of the relationship between two different data, like two different points of the data in a sense. And from there, once you have an idea of what you need to do, or at least what data you have, then you have to figure out what you need to find. And in order to find it, you need to decide what you need to do. And once you've decided all of that, you can start writing it out very nicely and smoothly. It'll be and you just make sure to not make any careless mistakes on your calculator. Significant figures usually is three significant figures. If certain values, very specific values are given, then follow the significant figures for that particular number that you get. I believe. It depends on the question as well. If the question asks you to follow a certain sig fig, then you do it. Yeah, that's the point. But usually it's three sig figs, so don't worry too much about it. Yeah, I think that's about it. We are done. If you found this video useful, please press the like button and subscribe. And with that, I would like to say thank you and bye.